These are the review answers for section 6 involving finding the exact values of problems with sines and cosines. We're given this information: the sine of y equals negative 1/3, and the cosine of x is negative 2/5. We know that y lies in between pi and 3 pi over 2, and that x lies in between pi over 2 and pi. And before I do any work with using my identities, I'm going to draw a picture of what's happening. So y has to be in between pi and 3 pi over 2, so that's in between 180 and 270. So y will lie in this quadrant. I'll label my triangle. Since the sine of y is negative 1/3, that means that the opposite of y is negative 1, and the hypotenuse is 3. When I do the Pythagorean theorem, I can find that this side is 2√2. And for my second picture, I know that the cosine of x is negative 2/5, and I know that x lies in between pi over 2 and pi, so x has to be in the second quadrant. Since the cosine is negative 2/5, the adjacent side is negative 2, and the opposite side is 5. When I do the Pythagorean theorem, this third side ends up being square root of 21. By knowing these two triangles, now I can apply my rules. The first rule that I want to apply is by doing the sine of x plus y for 6a. Now, following my identity sheet, the sine of x plus y is the sine of x times the cosine of y plus the cosine of x times the sine of y. So going back to my previous picture, the sine of y is going to be negative 1/3. We know the sine of x. Sine of x is going to be negative or positive 21 over 5. The cosine of y is going to be negative 2√2 over 3, again, because we're in the third quadrant. Then we add on the cosine of x, which were given in the original problem, is negative 2/5, and the sine of y, which is negative 1/3. So then we'll multiply together. We have negative 2√42 over 15 plus 2 over 15, which we can't really combine these numbers together, so the exact answer is 2 minus root 42 over 15. Six B asks us to find the cosine of x minus y. This identity follows the pattern: cosine of x, cosine of y, plus sine of x, sine of y. So we need to refer back to the pictures that we drew to figure out these ratios. The cosine of x, we're told in the original problem, is negative 2/5. The cosine of y, we found it's negative 2√2 over 3. The sine of x, we found 3√21 over 5. And the sine of y we're given in the original problem is negative 1/3. Now we'll just multiply. Remember, we can only add and subtract radicals if they are exactly the same. So our answer is 4 root 2 minus root 21 over 15. 6C asks us to find the tangent of y over 2. This requires us to use the half angle identity. Now there are multiple half angle identities for tangent. You can pick whichever one you want to use. I picked the one that did not involve a square root. I picked 1 minus the cosine of y over the sine of y. Now remember, we take our picture for y to follow this identity. We never have to know what the measure of angle y is. So here's my y picture again. I just have to plug in what I know. So 1 minus the cosine of y is negative root 2 over 2 over 3. And then over the sine of y is negative 1/3. I need a common denominator. This is 3 over 3. So I have 3 minus negative root 2 over 2, which is just going to be a plus. And then over negative 1/3. And then I'll multiply by the reciprocal. 3 plus 2 root 2 over 3 times negative 3 over 1. So the 3's cancel out. I still have the negative that I'll multiply both things. Negative 3 minus 2 root 2. $60 asks us to find the cosine of 2x. Again, there are multiple cosine angle identities for 2x that you can use. I just picked the first one, cosine squared x minus sine squared x. Let me get my x picture in here. So first I have to find the cosine of x. The cosine of x would be negative 2 over 5. And I'll square that. Minus the sine of x, which is the square root of 21 over 5, opposite over hypotenuse. Square both fractions. 4 over 25 minus 21 over 25, which ends up being negative 17.